Welcome to this new video. It's a next part of our previous ETL video. So in this video, we will be creating a sample ETL pipeline in GCP. So for that pipeline, this is a diagram, a flow diagram or architecture diagram, a very basic that you can easily identify, understand. So in this ETL pipeline, we will be using Cloud Composer. Then that Cloud Composer, it's basically Airflow with DAGs in it. So what it will do, it will pull up some data from some source. For now, we will keeping it simple. So there will be only one source, and that source is for ours particular this video is a share market data that we are pulling every day. So that data is now pulled in and is converted to CSV, and data is then stored in cloud storage. Don't worry about the type of storage that we are using. Let it be standard for now. Then that storage will trigger cloud function. This function will basically create a data flow pipeline, and then data flow pipeline will push that data that we have ingested in the cloud storage to BigQuery. So whatever data we will be receiving in BigQuery will be cleaned, transformed, and very useful. So as we have all this information in BigQuery, then we will be creating a Looker Studio, and this Looker Studio is something where the final dashboard will be created. So this dashboard is something where the business persons, stakeholders, decision makers uh, see the data, make their understanding and drive the business. So this is the architecture, and now let's see how we will uh, create all this diagram in GCP. So let's create our pipeline. For this pipeline, let's open GCP, and I suppose uh, everyone has GCP account, or if you don't have, uh, please create one, because there is also a free trial whenever you try to create this GCP account first time. So try to use it, play in it, and you will understand how it things works here. So we are now logged in our GCP account. This is one project that we have. That project is name is learning. This is the project ID here, learning 425301. So this is our project here in GCP. So as per our diagram, we will try to create our services that we will be using later to create the pipeline. So first thing is the Cloud Composer is very expensive, because whenever we try to run a Cloud Composer, it uses GKE clusters, and those clusters are very expensive. So for our demo purpose, we will create that cluster at the very end when other things are almost ready. So let's search for cloud storage here. So we have this cloud storage service, and this service will eventually be used to store our collected data from different sources. So we will start creating a bucket. Click on create bucket, and we will put some name, like let's say put it as dev1. uh, let it name should be, let it be yours, dev1 source ETL. Okay, so it will be our source. So now it's asking for multi-region. So let's keep it in one region, and it will be Southeast California for now. Then continue. Okay, now it is asking for the type of storage, so let it be standard for now. And the rest other things are very discrete things, so we don't go in deep of these things. Just we'll create it for our demo. So it's creating, and yeah, we will always enforce it to be private, so confirm this. US East 1 is our region and it's created. So dev1 source ETL is a bucket in which our cloud composer will collect the data and push the data for further processing. So first thing is done. We will create more buckets for our development purposes to storing the DAG files and other uh, things as well. So this is done. Now, as per our diagram, so now we will create a cloud function that will internally trigger a data flow for every batch of data it has been receiving from cloud storage. So let's create one. Let's search for cloud function. We know that cloud functions are now been renamed as cloud run functions. So I will create a new function just for the demo because it's important to show how things are done. So let's create a function. So we don't have to deploy a container or connect with the repo. For this thing we will create a function. So let's create a inline editor to create a function. What will be the name of a function? So let's say the name of function will be dev1 uh, let it be like cloud function to data flow. Okay, or let it be data flow. Okay, let's push this into our in the same region in which we have created the bucket. So it will be in South California. We will be using Python. So Python 3.1.13. The rest of the things will be same. We don't have to worry about that. Let's create a trigger. So this trigger is something that will be connected with your cloud storage. So we'll choose cloud storage trigger. So what we are doing here, like we are creating a trigger, and this trigger will be triggered every time some data has been pushed into our bucket, the bucket that we just created. Anything that is pushed in that bucket, this event is triggered, and this event is connected to our cloud run. So once event is triggered, cloud run will start processing that data that has been received in the data flow. So let's see this. So cloud storage, let trigger name, let it be the default one. Let's choose our bucket. So yeah, this is our bucket. So now we are selecting the bucket for which this cloud run will start its processing. So we have selected it. Okay, so the reason, yeah, so the reason is same, so error is gone, and just click save the trigger. So we also have created a trigger for this cloud function. Just click on the create. Okay, it's creating. So it's creating the service, creating the revision, routing the traffic, and finally creating the event trigger. So it is done, and this sample function is in front of us. Okay, so just to save some time, I will copy paste one such function written in Python, but I will give you a walkthrough like what that thing is doing. So let's copy that. So this is our function that will be used. So let's Control A, Control C, and paste it here. So, so let's go one line by line. So these are some dependencies that we will be importing so that this function can start working. So this is the initial function. That function will be called when any file is uploaded to bucket. We have given the name here of the same function because Cloud function must know which function he has to call when any file has been uploaded to storage Cloud bucket. So once the file has been uploaded, we can get the data from that cloud event that has been received from the event that we have created. If you remember, we have created an event track, so that event is same here. So we have received that event. We will extract the data from the event. We will extract the event ID. We extract the event type. So these are uh, some parameters, some values we will extract. We will also extract that bucket name from the data that we have extracted from the cloud event. Then we also extract the field file name. So file name will be the name of the file that has been uploaded to the bucket. This also has some information about the meta tag of that particular file, the time when it's created, the time when it's updated. So these are some extra details, but we will require these two informations only for our in this purpose, bucket name and the file name. Later we will also give the region. So our region is US East 1, so let's change this. Region will be US East 1, East 1, so it's done. So now region is also same, and the project name, if you remember here, this is the project ID, so we will also add this project ID here. Next, this is the template part. So what is template path? So this template path we will be using to create the data flow pipeline. So as we know, data flow is something that is used to create a pipeline that basically process the data. It's a kind of a flow chart. If I can make it in a simple way, it's a flow chart like how data will move and how data will be cleaned. So this is how it's done, and probably we will see how it will be done later, but for now this is a template, and this template is particularly given by default by Google, and you don't have to worry about creating Python files and writing Apache Beam functions to create the data flow. It's a template. You just use that template and it will do your thing. So it's a very simple way to use it. Yeah, I mean, when you have some complex scenarios, complex structures, then obviously you have to go with the Apache Beam, and then you have to write some complex functions, complex dependencies, paths to complete your data for pipeline. But for our use case, it's very simple, so we will be using this template. So this is the path of the template, and we have to also change the this URL as well. So let's put it like this. Okay, it will be the latest one, and the name will be the GCS text2 BigQuery. So we have this template path set. Now let's come here. It says like we have to prevent our cloud function to process the same file every time. So how we will stop this? So let's do one thing. For now, start with, okay. So let's put the name of the cloud function that we have created here. So let me create a duplicate here. So we have this duplicate open. I need to copy the name of that cloud bucket. So let's go for the buckets. We have the buckets here. So the name is dev1 source ETL. Let me copy this. Come here. Paste the name. Okay. So it's there. It will prevent from processing it again. Now we will be using the credentials as default. So this default is something coming from the Google Auth. You don't have to worry about this. And this is something that we require to create our data flow pipeline. So see, this is a build. We want to build a data flow. This is the version, and this is the credential that we created. So our data flow build object is with us. Later we will use it to create the data flow. Now this is the template body. So you remember we have created a template path. So this is a template path that we will be providing to GCS as a GCS path to create the data flow. But we also need a template body. So template body contains the details of your data flow, because template is something that is used to create the behavior of your data flow. But running a data flow, it requires information of the structure of your data. Maybe if you are trying to do some transformations on the data that you are getting from the bucket, then you also have some JavaScript functions that basically transform it. So let me show that these two files to you. Okay, so this is a UDF file that is generally required by uh, data flow in GCP. It contains the list of all the data and what is the place of data and how it been organized in your CSV file. So it contains all the information, and it will allow you to transform the data so that it can be stored in a proper manner in your BigQuery. So this is a transformation file that is required, and then you require a JSON, BQ This is what it tells BigQuery, like what is the schema of this data that we are going to push in the BigQuery, what's the type of the data, what is the name of the field. So these all informations are required, and these all informations are provided in the template body. So these are two files that we will be uploading in a separate bucket. So let's go back to our console. So this is the transformation thing. So UDF file, as I displayed you, then the BQJSON thing, and then the JavaScript. This is the name of I would say function. So in our case, in the UDF file, it was transform function. So we have given the name of the function here. Then output table. So this is the this will be the table name where this all data process data will be stored in BigQuery. So this is the output table path, and this is the pattern of the input file. So this is simple, like the bucket name and the file name. It's simple. So this is not to worry about. Next is the BigQuery temporary directory. So for now, we will create we will give a directory or a bucket name where the temporary things of the BigQuery will be loaded. So we will giving it as this name. But now let's create this folder here with the same name. So let's go to this one, buckets, create one more bucket. In this bucket, we will put all our other required things. So one single region, South Carolina, and create. So now we have created one more bucket that will store the configuration files. So this is created. Now we will try to upload the files. So these two files are now uploaded. It's done. We have these files here. So these two files, UDF and BigJSON, is now uploaded, and the path is the same. So we are done with our template body. So now data flow knows what to pick, where to pick, what to transform, where to push. Okay. So now this is the uh, way how we launch our data flow, and we will be creating a data flow pipeline every time a new file has been uploaded to the bucket. So I think we are good till here. Let me do one more thing. we must need to install these dependencies. So we have the requirement docs.txt. So let's copy. So let's copy it, all dependencies that are required. Open this thing, paste, and now we will deploy this. So now it's deploying our updated code, updated details. So meanwhile, it's deploying our Cloud Run. We will create our BigQuery dataset. So dataset name will be dev1 GCS sync. Okay, it could be anything. For me, I have kept it this way. Let's open the BigQuery. Probably I had already created one, if I'm not wrong. No, I don't have any. So let's create one, create a data set, put the name here, region, select the same region, uh, South Carolina. Okay, and you don't have to do anything, just create. So now we are creating a data set in BigQuery, and in data set we have to create the tables. So create a table. This is the data set, this is the table name. Okay, and we don't have to worry about the schema because we already have provided the schema in our BigQ JSON and all the details in a transformation file. Okay, so let's do it. Let's create it. Okay, so our table is now created and we are good with the BigQuery. So now we have created all the services. Only two services are left. One is creating a composer that will run Airflow thing, and the Looker dashboard. But I was thinking let's create this in our next video because this video is now more than 20 minutes. Okay, so let's meet you guys in the next video. Thank you for watching this video. Take care.